0, closed circuit. Open line, closed circuit. From left to right. Position 1 is the light for the cavity. Position 2, terminals 1 to P1 remain active as evidenced, and 2 to P2 control the convection fan. Position 3 controls the top outer element and the bake element, P3, P5. They both come on at the same time. Position 4, convection bake. Convection fan, terminals 2 and P2 control the convection fan, 3 and P3 control the element. Terminal 1 to P7 should read our local voltage. We do not because the clock is not set. We should have 208 to 250 volts. 1 to P7 where we test for local voltage. We do not have 208 to 250 until we set the clock. To set the clock, press the second and third button simultaneously, release simultaneously, and immediately use the fifth and sixth button to set the time. From 1 to P7, 212.3 volts, local voltage. Number 1 brings the power to P1. If P1 is broken, when the switch is on, you'll read 250 volts. We don't read any volts because our switch is not broken. The thermostat takes P1, which is L1. P1 comes into terminal 1, leaves at P1, enters the thermostat, comes out in a double white wire, feeds terminals P4 and P5, which brings L1 out to the cooling fan, convection motor, and every element. Up to this point. After P6, this is where we introduce L2, the red wire. The red wire connects to the pilot light, bake, broil, convection element, and top outer element. Terminal 8 feeds the cooling fan. Red wire to orange. The orange wire additionally connects to 2 cooling fan thermostats. Whenever the contacts are closed, the cooling fan receives voltage even if the selector switch is off. If the thermostat is bad, you can read across the 2 terminals and you'll get 208 to 250 volts. Any broken component and you suspect the selector switch, test from 8 to P8 and you'll read 120 volts. Or simply unplug the unit, disconnect the wires, and test for ohms. This is a 55-degree thermostat, as evidenced by the red dot. It is in parallel circuit with terminal 8 on the selector switch, which controls the cooling fan. In the event it is hot in this area, when you turn the oven off, the cooling fan will continue to run. Additionally, we have another thermostat, 80 degrees centigrade. Note, again, parallel circuit to the cooling fan. In the event it is hot in this area when you turn off the oven, the cooling fan will continue to run. To test your thermal cutoff, set your meter to ohms, touch your probes together to make sure your meter works. From the orange and red to the red, you should have full circuit. There we go. And between the double blue and the single blue, you should have full circuit. In the event the oven is too hot, it'll trip and you'll have no circuit. Here's your cooling fan. To see that the cooling fan works, follow these 2 black wires. Black wire goes to neutral, other black wire goes to the safety thermostat. Insert 1 wire on each and you'll see the circuit closes. You see the meter? Open line, closed line. Here's the back side of your operating thermostat. It should read circuit when it's calling for heat. Above 70 degrees room temperature. We have circuit. In the event we do not get circuit through this piece, simply remove the white wire, remove the blue wire from P1 of the selector switch, jump in the white wire, and it'll work. The only thing, it will incinerate the food. But this is to make sure it's going to work after we change the thermostat. In addition to using the wire in the stove to jump out the faulty part, we can use a little regular jumper. 1/4 inch male spade by 1/4 inch male spade. Energized unit, set clock, test. This is a good way to test, or alligator clips. Voltage comes in on P1 and P2. When you turn up the power regulator switch, it leaves on the orange and double gray, S1 and S2. L1, L2. The Italians like to use red for L1, blue for L2. From L1 to ground and from L1 to neutral, you will have about 110, 120 volts. Same thing from L2 to neutral and ground, same voltage. And across L1 and L2, 208 to 250, depending upon your local voltage. Note, even though you have the proper voltage, turn on the oven and retest the voltage. The incoming line could have a loose wire under a screw or on a circuit breaker or the ground bar where you'll lose the neutral. So perform the same 3 tests with the oven on if you got a failure. This is your E61 relay. The middle row of wires always reads the local voltage, independent of the clock being set. You will always get the same voltage here as here. When it is off, you will also get the same local voltage here. The electromagnet in the relay is 208 volts. If you notice, these 2 wires always have L2. L1 comes down the white wire from the sales switch to energize the relay, at which point the voltage leaves the outer terminals and goes to these 2 terminals. This blue wire brings L1 to the front left terminal, terminal 1 of the selector switch. L2 travels through the safety thermostat, 150 degrees centigrade. To test it, put it on your ohm meter and you'll read ohms through it. If it's faulty, which this one isn't, 2 ways to approach the situation, because we always like to test and make sure the oven's going to work. Put a jumper in. Plug in the oven, set the clock, test it. This way you know it will work. If you don't have a fancy jumper, just take a piece of wire, cut it, strip the ends, and poke it right in there. As you see, when the thermostat calls for heat, we have circuit. As I lower it, you will get a little click at approximately 70 degrees, and the circuit opens up again. That's the point when it's cold that you should get the click. If the oven is running hot, we turn the hub clockwise to lower it. Find the detent. Mark the detent on the hub for a point of reference. Strike a mark. To lower the temperature, turn the hub clockwise. This handy dandy little homemade tool fits perfectly. To make the temperature higher, turn the hub counterclockwise. If you're doing it with the power off, again, just listen for the click where 70 degrees should be. Remember, keep it level when you do it.